week, we are going to be doing a specific heat laboratory, which is going to utilize our Q equals MC delta T equation in order to help us determine the identity of an unknown metal. Some important information to take note of for this lab includes that the transfer of heat is always going to occur in one direction, and that occurs from objects of higher temperature towards objects of lower temperature. So what we're going to be doing is heating up a sample of metal, and we're going to place it in a sample of water, which is going to be within this calorimeter. And the calorimeter is going to insulate the sample of metal, and it should heat up the water. What you see in front of you is a list of the materials that we are going to be using. So we have our main character in our lab, which is the sample of metal that you're going to be filling out as you watch the video. This is our page for calculations. So you will be recording the data, and that'll be right here in this table. So the units are already placed for you. So all you have to do is input the values that we find while doing the lab. Temp water in the calorimeter. So it says final temp minus beginning temp, and we have to do E minus B. So E minus B is going to tell us to do 21 minus 20. So I'm going to go ahead and show that. So 21 minus 20. We're going to have a change in temperature of 1 degree Celsius. So a lot of our practice calculations have involved us using joules divided by grams times Celsius, but in this case, we're going to use calories. So we're going to use 200 grams because that is how much water I placed in the calorimeter. So 1 ml is equal to 1 gram, so I put in 200 ml, so 200 grams. And we have the specific heat of 1 calorie per gram times Celsius. We also have the change in temperature of 1 degree Celsius. So 1 degree Celsius, and that comes from our calculation in problem 1. So it should be 200 times ln times ln. Our Celsius cancel out. Grams are going to cancel out, so we'll be left with 200 calories. All right, so we're going to move forward to question 3. So we're going to do F minus D. So this is going to be 20 degrees minus 223. And you're probably noticing that it's going to lead to a negative value, and you are correct. So I showed how you do this on the calculator, and it is negative 203. So we're going to see how this plays a huge role in determining the specific heat for this metal. So now we will use the energy value that we found in question 2. However, it's going to be negative in the case of metal, and that's because when the metal heated up, it lost heat when it was placed into the room temperature water within the calorimeter. So this is going to be negative 200 calories, and it's going to be equal to the mass of the metal, which is equal to 3.671 grams, times our change in temperature, which is negative 203, times our specific heat. Okay, so now we're ready to begin conducting this calculation. So let's go ahead and I will multiply so that you can see what we're doing. So 3.671 times negative 203 213 CP equal to negative 200 and we're going to divide. So 200 divided by 745.213 and we end up with a specific heat of let's see what that was again, 0.27. So we'll just go ahead and round 0.27. And our units for this are going to be, so this is in calories. This is grams times Celsius. So 0.27 calories divided by grams times Celsius.